Okay. So hi, my name is Jae Hyuk Kwak. Yeah, my hotel Wi-Fi is not good enough bandwidth, so let me turn off my video while am I speaking. So next 35 minutes, I'm gonna talk about the debuggers and the tools. So now I'm on the 02_a debugging.md file. So on Aurora, we have two debuggers. One is GDB1 API. This is a traditional GDB debuggers the extended for the Intel GPUs. And another the debugger is the Linaro DDT. Previously it was ARM DDT, before it was a linear DDT too. So this is a pretty popular parallel debugger. So I will show you how to find these two debuggers on Aurora and how to run it with a simple example. So before we start the debugging, you need to compile and link your application with -g, which is required for the debug symbol. For the best experience, we recommend to use -g-o0. So with some optimization, some variables can be optimized out, so we may not be able to see what happened in that variable. So the best debugging environment, you had better build your application with the -g-o0 flag again before you're debugging. The another point you need to remember is in the Aurora compute node, for the performance, we disabled the debugging mode. So in order to debug your code on Aurora compute node, you have to explicitly enable GPU debugging mode, debugging configuration. So for that, you need to use this kind of shell script. So we named it helper toggle EU underscore debug.sh. So later we will do some example, and your GitHub repository already have this shell script, so you don't have to copy and paste this one. You can just use that. So the point is, once you have this shell script, and then start your interactive job mode. For example, you may have one node for the practice. So you need to run the npi exec-n1 and run the helper toggle eu debug.sh and put the 1, which means you change your GPU to the debug mode. And then you have to export this environment variable so your debugger can functional with the debugging mode. So this two line is required before you start debugging. So this is a common part for the GDB debugger or the DDT debugger, both of them. So Intel GDB debugger, the GDB1 API is already included in one API module. So whenever you log into the system and then getting the node, compute node, you already have one API module loaded. So you don't have to actually load one API module, so you already have GDB1 API. So you can type the GDB1 API version and you can see this version. And then how to run it. So for the single GPU, you can just run gdb1 API -q and then your application and some command line argument. Simple. And MPI, with MPI application, you need to use MPMD mode, multiple and multiple data mode, using the MPI. So in this example, and then you also need to use xterm to see the GDB output. So in this example, I run the application with the 4 MPI rank and I attach the GDB to the second MPI rank. So MPI run -n your application and colon -n and xterm-e gdb1 API-q your application and then colon -n2 your application. So this is not really convenient way. So it is why you want to use another parallel debugger DDT. So if you want to do the parallel debugging, you may use the DDT directly. So DDT is from Linaro. It's a pretty popular parallel debuggers available on many clusters. So in order to use that, I put this link on your the chat. So you need to download the Linaro Forge client version, 24.1.1 version for now. So download it and install it. And then once you get it, you can start your remote client here. So if you run the remote client here, as you can see here, this client is popping up. This is on your laptop. And then what you need to do is you need to click the remote launch and click the configure. So you need to make a configuration for the Aurora. And then you need to add here So let's name the connection name as Aurora. And then the host name, JPEG is my host name, so you cannot use it. You have to use your host name. And then at the login, Aurora alcf.anl.gov. Okay. Sorry. And then you need to specify what is remote installation directory. So in here, for now, we have to use this location for the DDT path. So I just copy and paste here. Remote installation directory. So paste here. And then if I just test remote launch, it will be testing. Then it shows it's successful. So in my case, I have some additional SSH config. So I'm not asked to enter the Aurora credentials. If you don't have that, you probably need to type your Aurora credential again on this terminal, and then you can finish your testing. Okay. So this is how to configure your client Linaro client to the Aurora. So once you do that, on your compute node, you need to load module, the Forge module. So module load Forge, and then you can find the DDT version 24.1.1 version. So how to run DDT? So you need to connect to Aurora first. So I'm connecting the Aurora. And then you can see connected to JCog at login and aurora.alcf.anl. So you probably be asked to enter your Aurora credential again. So if so, you need to type it. And then now your client is ready for the DDT debugging. Okay, here. And then on an interactive job mode, after enabling your debugging mode, you need to run DDT-connect. So in this example, I use a 12 MPI rank and connect in your application. So if you run that, on your client, the new window will popping up. So a reverse connect request is available from X4345G. This is compute node. So do you accept it? And then you need to click accept, and then you can start debugging. Okay. So this is kind of the very, very quick overview of the one API GDB and the DDT, and I will show you with some example. Before moving on, do you have any question? Okay, let me move on. Okay, so I was lucky to get a note now. So this is my note, and let's go to the rooster and the flare and project LCF training, and I created a JPEG. So I already cloned this GitHub repository. So let's go to ALCF, the beginner guide, and then the Aurora example and 02 tools example. And then you can see, yeah, you can see these 5 files here. Okay. So before we start, let's build the application first. So you can just make, and then it's very, very simple benchmark. And then you can see the two executable ending with the DP, and another is ending with underscore debug. So you will use this executable for debugging example. And then we need to enable the debugging mode on this compute node, right? So what I need to do is I need to run npm -n and helper toggle EU debug 1. So if I run it, you can see EU debug status on rank 0, 1, 1, 1, 1, 1. So your 6 GPUs on a compute node, the debug mode is enabled. And then you need to pass this debugging environment variable GT enable program debugging is equal to 1 to here. So now your compute node is ready for debugging. Okay. And then let's do the GDB one API debugger. So we already created it, and then let's run it. So if you check module list, you already have the one API module here. So you have GDB, one API. You can see that. So GDB one API dash Q, and then compute, geoseries, MPICC, and DP, and debug. Okay. So if you run it, the GDB window popping up, and then let me set the breakpoint. Geocity, OMP.c, and then let's put the line 32 for the breakpoint. And it says breakpoint 1 set at this file line 32. And then let's try to run it. So now you're seeing the standard output from GDB and my application. So it's kind of running. So once you run that, I set the breakpoint and then I just run the GDB, right? Oh, great. The issue with reservation is resolved. So you guys should have the node. That's great. Okay. And then it takes a while because you build your application with -0 and the debug symbol. So overhead is pretty higher than your usual runs. So you should be a little bit more patient. So once the debugger hit the breakpoint, you will see this kind of message. So the thread, the number hit the breakpoint 1, something like that, which is the number 32, ID, IJ, multiplied by the N. So let's give it a little bit time. And then once the debugger hit the breakpoint, you can see the list to see what is the source line. Okay, now it hit the breakpoint. And then you can type the list. This is kind of general GDB, uh, the the instruction, right? So, and then I need to set the set scheduler locking step. So this is required if you want to do the step with that specific thread. So, and then I just do the step and move to line 33, 34, 35, 36. And this is for loops, so it takes a little while, and then move to the 37 soon, or 38 soon. And then maybe I can just print what is the temp result. I can see the print temp result. I can see the data, right? And then you can also see the backtrace and etc. So this is kind of general GDB instruction. So you can just see how to use the GDB for Intel GPUs. So it will detach now, right? And then you may want to run the GDB1 API with the MPI executable. For that case, you have to establish X11 forwarding from your local system to Aurora using SSH-Y login. And then on the login node to the compute, you need to run your interactive job mode with -X to establish X11 forwarding. So yeah, I don't think we have enough time to reestablish everything, so I may just skip it. So in this example, I just run the MPI run dash and GPU compact and xtom. So I just attach the GDB1 API to the rank 0, and then the other 11 MPI rank just run without GDB. So if you run it after you establish X11 forwarding, and then you will see the another window popping up, X window popping up, and then you can do the exactly same thing what I did for the GDB1 API in the serial version. Okay, so that's how to use it. And then let's try to use the DDT. Okay, so I already connected my client Linaro Forge client to the Aurora. So I see the connected jQuery login and Aurora alsf.ann.gov. And then what I need to do is I need to load module Forge. Then I can see the DDT here, right? And then we need to make the connect, reverse connect. So here, DDT -mp12 and the connect -mpi argument, ppm12 and environment all, and then compute geoseries and debug. Okay. So if I just run it, And then on your client version, you can see the new window popping up. So reverse connection requested available from this compute node. You can just accept it. And then you will see another window popping up for the configuration for one. So as I typed on the CLI, you can see the MPI argument is here, number of MPI is 12, etc. Right? So I can oop, run it. And then you can see DDT started, waiting for process to be ready and process ready, something like that, right? So it takes some time. So let me go over with the screenshot. So once, okay, so now we accepted and then we just run the case and we are listening for the program. DDT is listening for program. So once it is done, the DDT will stop at the very first line of your application, right here. And then you may go to some line of interest. So previously, one GDB, one API, we put the breakpoint at the line 32. We can do the same thing, just scroll up and then go to line 32. And then you can do the right click and you can see this another window. So you can set the add breakpoint all. And then set that and then just run with this triangular button icon. So if you just click that, your DDT started running your application with all the 12 MPI rank. And then it takes some time. And then at some point, once one of your process hit the breakpoint, you will see another window popping up. So process stopped at the breakpoint in this line. Do you want to pause? So you can just pause. And then you can see on the right window, right pane, you can see what is local variable, what is command line, the kernel stack, and GPU device, etc.